Hello and most welcome to H 1909. We are progressing towards the new millennia. So it's almost a decade up and merely 90 from the 2000. It's progressing swiftly. I would today start with a little check out Wittgenstein's view of mathematics. This is to clarify how mathematics is also used by Wittgenstein to look at use and getting rid of Platonism within mathematics. I will not take this very article by odd surname guy, Richard Startup. I will start up a bit later in the article, actually at subchapter 4. I do not want to dwell too much into diacritics and complicated mathematical arguments, nor references to Tractatus. So we'll go to chapter 4 and we'll start there. You have the page number at the bottom.
Page 52.
You can make it a bit larger.
Okay.
The development of number and its grammar. Grammar. Where's my grammar? In addition to his concern with the relation of meaning and proof, in his middle period, Wittgenstein directed a lot of attention to the number concept, and in particular to issues to do with the infinite. Adopting a more argumentative style, he is led to challenge aspects of the letter notion as used by mathematicians, especially what he terms infinite mathematical extensions. The intention here is to track both the predominant approach of mathematicians and his critical view, so as to assist an evaluation. In this connection, it is important to direct attention both towards the nature of mathematical propositions or pseudo-propositions. Pseudo-propositions.
Pseudo-problems.
Pseudo or Zulu propositions, and also the development of the number concept. A good example of change in the number concept has in fact already been alluded to, for in the last section reference is made to the emergence of complex numbers. The issues are perhaps best approached via the most basic and even elementary seeming concerns. Concerns. In his remarks on the foundations of mathematics, Wittgenstein situates mathematical verification and relates it to the determination of meaning. This links to his doubts about infinite mathematical extensions.
Extensions.
Extensions. Extensions. True propositions within mathematics have that status because they are provable in a calculus. They are deductions from axioms by formal rules and are true by virtue of valid application of the rules of inference. They owe nothing to the world outside mathematics. The key point is that a mathematical calculus is a calculus for the transformation of signs. However, as Wittgenstein puts it, mathematics is not a mere game because the natural numbers have a use outside mathematics. And this use of numbers in ordinary language is what gives mathematics its meaning. In an oft-quoted passage, Wittgenstein says, "It is essential to mathematics that its signs are also employed in mufti." It is the use outside mathematics, and so the meaning of the signs that makes the sign game into mathematics. The equation 2 plus 3 is 5 is a derivable consequence of the definition of addition in the sign calculus of mathematics. But if the word changed so that it ceased to be the case that whenever we placed 3 eggs in a box which already contained 2 eggs, then only 4 eggs remained instead of 5. The equation would retain its mathematical validity but lose its application in the world. Indeed, yeah.
Which sound does the hens make?
Hmm.
Kukelikoo? No.
The failure to find a use for the equation outside of mathematics would deprive it of meaning. Mathematics is applied but not verified in the world. Some developmental stages for number.
Number.
Moving next to the overall developmental picture for number, particularly as this is understood by mathematicians. One may perhaps say that the concept has evolved, where this is meant in the original sense of unfolding. Originating with the natural numbers, systematic development has occurred subject to the principle of generalization. At the same time, the discipline of mathematics has been integrated by the coming together of algebra and geometry within analytical geometry. Indeed. Geometry. There is a perceptible passage towards completeness, the source of which becomes clear as particular stages are briefly adumbrated. In the arithmetic of the natural numbers, one can always carry out the two fundamental operations of addition and multiplication. But the inverse operations of subtraction and division are not always possible. The steps towards removing the restrictions were taken when the symbol 0 and the symbols for negative numbers were introduced.
Negative numbers were introduced.
Indeed, they were introduced. Here. This ensures that subtraction may be performed without restriction in the domain of positive and negative integers. Integers.
Mhm.
It is necessary in this connection to define operations in such a way that the original rules of arithmetical operations are preserved. Thus, the initially strange-seeming rule -1 plus -1 or times -1 is +1 is a consequence of the desire to preserve the distributive law of multiplication. Equation to be read. What has just been said may be contrasted with elements of Wittgenstein's distinctive perspective.
Perspective.
Perspective. He would have been aware that when negative numbers first made an appearance to handle debits as well as credits, as numbers, they were greeted with the same abhorrence as were imaginary numbers later on. That abhorrence arises from violation of the existing syntax or grammar associated with natural numbers.
Natural numbers.
In the natural number system, it makes no sense to subtract a larger from a smaller number. The integers constitute a new number system, and it is misleading to consider that as an expansion of an old number system. Associated with a new numerical series is a new grammatical system, which is such that analogues of previously unintelligible questions acquire meaning and become soluble. What happens is that a new system extends the family of systems gathered under the concept of number. Indeed. One may briefly track the further development of number. The introduction of fractions removes the analogous arithmetical obstacle to division. Rational numbers are provided with a geometrical interpretation, enabling the magnitudes of line segments to be compared. Analytical geometry enables every geometrical object and operation to be referred to the realm of numbers.
Yes.
Each of these systems has its associated grammar. Grammar.
Grammar. Acram of hash hash.
A further development concerns the definition of real number system and irrational numbers. Since this last is a focus of many of Wittgenstein's comments, slightly more detail is provided here.
Cliffhanger.
Numbers may be expressed to any whole number base greater than 1. But the reader will be familiar with the fact that we customarily express numbers to base 10 and also use place value. Furthermore, one can cover the number axis with those numbers which originates by subdivision of each unit interval into 10, 100,000, etc. Equal segments.
Equal.
Equal! The points so obtained correspond to decimal fractions and give rise to the familiar representation of a number in the decimal system by the abbreviated symbol Z, A1, A2, A3, up to A infinity or whatever. Informally, one then proceeds to define the continuum of real numbers or real number system as the totality of infinite decimals. As indicated in an earlier section, all rational numbers are either finite or periodic decimals. The irrational numbers are the non-periodic decimals.
Irrational numbers. Irrational. Irrational.
5. Infinity and irrational numbers. A key difference between the early and middle Wittgenstein is that at the later stage, he rejects quantification over an infinite domain. Strategically important in this connection are his conception of mathematics as a human invention and the notion that mathematical calculi are exclusively made up what he terms intensions and extensions. His usage is unconventional extensions, he means such items as symbols, axioms, propositions, and finite sequences. While by intentions he has in mind rules of differing kinds, such as rules of inference.
Rules of inference.
Rules of inference. Wittgenstein casts doubt on the idea of actual infinite sets. The infinite number series is only the infinite possibility of finite series of numbers. It is senseless to speak of the whole infinite number series.
Senseless. Senseless. It is senseless to speak of the whole infinite number series. I say two per an extension.
Additional comments of his bear upon the distinction between the actual and the potential infinite. He argues more directly against the existence of infinite sets as follows. Let's imagine a man whose life goes back for an infinite time and who says to us, I'm just writing down the last digit of pi and it's a 2. Every day of his life, he has written down a digit without ever having begun. He has just finished. This seems utter nonsense and a reduction ad absurdum of the concept of an infinite totality. Taken literally, this is unsatisfactory since pi is irrational. Its decimal expansions does not terminate, so it has no last digit. To say that the expansion has no last digit is a clear idea which has nothing to do with time. Therefore, its clarity cannot be challenged by way of an imaginary exercise involving performance in time.
In time.
In time. There are indeed several points in his writings where Wittgenstein appears to query the actual infinite and infinite mathematical extensions, which has given rise to discussion as to whether his approach may fairly be characterized as finitist.
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 How do you dare?
How do you
Finitist.
dare? Indicative in his claim that the concepts of infinite decimals in mathematical propositions are not concepts of series, but of unlimited technique of expansion of series. He also affirms that the extensional definitions of functions, of real numbers, etc., pass over, although they presuppose everything intentional. He asserts that irrational numbers are rules for constructing finite expansions, not infinite mathematical extensions. Alluding to the method of defining irrational numbers by the use of Dedekind cuts.
Guts. Guts. No.
He queries whether we are led to the square root by 2 by way of the concept of a cut, and characterizes the cut as an extensional image. Of critical importance in his claim that there is no rule, no systematic means of defining each and every irrational number intentionally, which leads him to the question whether there is a criterion for the irrational numbers to be complete. Irrational numbers, definition, examples, are criterion for completeness. What Wittgenstein appears to mean by defining an irrational number intentionally is illustrated by the definition of the square root of 2 as the length of the diagonal of a unit square and pi as the length of the circumference of a circle of a unit diameter. Both definitions are geometrical on their face, but one must bear in mind the geometrical interpretation of number noted earlier. On the other hand, what Wittgenstein has in mind by a mathematical extension would appear to be illustrated in the present context by the representation of a quarter by 0.25, where the 2 digits after the decimal point are specified and ordered. What he would appear to be objecting to in an infinite mathematical extension such as the representation of the square root of 2 as 1.4.4 and so on, is that only some of the digits are individually identified and ordered. Part of the response is to say that if anyone cares to specify any arbitrary whole number, such as 100, a further extension may in principle be provided to reveal further digits up to the specified whole number of decimal places. The other part of the response is to say that it is not possible to specify a last digit because there is no last digit. It is important to make more precise what is being said about square root of 2 and pi. The basic assertion is that each gives rise to an indefinitely extended decimal fraction.
Decimal fraction.
Yes.
Decimal fraction. Decimal.
Decimal. In the first case, no explicit formula is known to determine the digits, but one may calculate as many as one wishes. In the second case, there are formulas which enable pi to be expressed as an infinite series from which its decimal expansion may be determined to any required degree of accuracy.
Accuracy.
Thus, each may be shown as an indefinitely extended decimal fraction of the form ZAAAA, where the dots indicates that the decimal fraction may be extended indefinitely. This implies that were someone to require an extension to an arbitrary whole number of decimal places, it could in principle be provided. The root of 2 and pi are irrational numbers, but it is pertinent to add that many rational numbers give rise to an indefinitely extended decimal expansion, albeit one which is periodic. The most familiar being the expression for a third as 0.33333. Thus, there is a perfectly clear sense in which the real numbers or the real number continuum may be considered as complete. Within that context, square root of 2 and pi belong to the irrationals, the non-periodic decimals. Which may also be considered as complete.
Complete.
Wittgenstein is critical of a tendency to employ metaphors deriving from geography. For instance, claim that irrational points fill the gaps on a line left by rational points. Just as we might claim that certain sediments fill the gaps in a rock left by igneous metal. No responsible mathematician would do this, however. For one thing, a gap would be a measurable interval. while an indefinitely large number of rational numbers is found within any interval, however small. Again, he writes, we are surprised to find that between the everywhere dense rational points, there is still room for the irrationals. No one is claiming, however, that any room or interval is either needed or available to accommodate irrationals. As noted above, each is being defined as the limit of an indefinitely large sequence of rationals. In the latter connection, there may well be employment of such formal phraseology as the limit as n tends to infinity. But this is used rather as a term of art.
Art. Term of art.
It carries absolutely no implication that infinity is to be treated like a natural number. In seeking to identify a criterion for the irrational numbers being complete, Wittgenstein argues as follows. Suppose we have the totality of all irrational numbers with one single exception. How would we feel the lack of this one? And if it were to be added, how would it fill the gap? Suppose that it's pi.
Pi.
If an irrational number is given through the totality of its approximations, then up to any point taken at random, there is a series coinciding with that of pi. And so if I have the totality of all irrational numbers except pi, and now insert pi, I cannot cite a point at which pi is now really needed. At every point, it has a companion, agreeing with it from the beginning on. This shows clearly that an irrational number is not the extension of an infinite decimal fraction, that it's a law.
Law. Law. Law, not law.
No, not love. Our answer to the question above must be if pi were an extension, we would never feel the lack of it. That is, it would be impossible for us to observe a gap if pi were to disappear, or the extension of pi? In what space would it disappear from? If someone were to ask us, but have you then an infinite decimal expansion with m in the rth place and n in the s place, etc.? We could always oblige him. And I put a stop there, 1309. Oblige him as far as we can.
Page, let me see, page 57.
So, what is said here? Well, let's start with maybe the last I read. And I think that could scramble out some memories here. And if we go up there, this shows clearly that an irrational number isn't the extension of an infinite decimal fraction. That it's a law. What's meant here? Well, there is no way of sort of producing irrational number from an infinite decimal fraction. It doesn't have a system or an abstract system. It's more of a doing. And be careful here. Here it's called the law by startup, or Wittgenstein actually. But we've been using law in the sense of classical laws before, of physics. Here it's used quite differently. It's a sort of doing. It's a stewing. The law is a doing. One could speak of the grammar of mathematics. So you will recognize the Wittgenstein that we learned about here in mathematics. There's no need to suspect something completely different. Page 53. It is essential to mathematics that its signs are also employed in mufti. It is the use outside mathematics, so the meaning of the signs that makes the sign game into mathematics. So it's outside, the meaning is coming from the outside of mathematics. It's not within mathematics. Once more, we have the exo, the outside. And if you want to sort of think of something similar, think of Lakoff-Johnson or Barbara Tversky, then you will be pretty close to home. And I think in the next example coming here about the eggs.
Nami.
Yeah, eggs are good.
Kukelikoo.
Kukelikoo. Well, the cock never lays any eggs, but he's part of the production. Sometimes, anyway, sometimes, yes. And if we were to put 2 eggs together with 3 eggs and end up with 4, oh no, 1 egg missing. It would lack its criterion in the world. And that's an important point. Very close to what was said about language. words without criterion, concepts without criterion, use, actual use, in the real world, lack meaning. The failure to find a use for the equation outside of mathematics would deprive it of meaning. Yes.
No. No.
So you see here, use is in here, meaning is use. The stage setting comes again, and you can put this, as will be done now, to space itself. Often space is used to explain pi and other things, and you get a sort of arithmetical space. See, I can maybe put that to the... Okay. So the space created here is in between. So if you have these two, they fill up the space of the number series. And all of a sudden you created a space that exists beyond this world, beyond criterions. And this is pretty close of the infinity of the universe. The Newtonian space that is created also by these things, by real numbers actually. Something that has been questioned quite recently. It has actually even been proven that irrational numbers or real numbers, especially real numbers, do not exist. There is no room for them. This is a variety of that. He's going even harder, says the idea that it fills up bits of space is a miscalculation, is a misconception. There is no space parallel to these things that fills up some room somewhere, because these are actually uses. You handle them with your hand. You do them. They are not transcendental or Platonic, or at least not that Platonic or transcendental. So once more, Wittgenstein is bringing everything to use, criterion, stage setting. And mathematics is not by itself, it is dependent on what we do. It's very close to Barbara Tversky and Lakoff Johnson. Although it's Wittgenstein once more, even though it's mathematics. I'm sure you recognize him as such. He brings everything down to where it stems from. And the confusion of the mathematical space being organized this way, whatever that would look like, is shown to be nonsensical. I'll pause and continue from here. I continue here on page 54 under the subtitle Infinity and Irrational Numbers. And the fifth line here, his usage is unconventional. By extensions, he means such items as symbols, axioms, propositions, and finite sequences. While by intention, he has in mind rules of differing kinds, such as rules of inference. So all of mathematics is done. He's still not a constructivist, but most definitely he shows that it is not coming from a Platonic world beyond. He shows once more it comes from the tools that we use. So the symbols are tools. They are scribblings on a piece of paper. They are the calculator. They are exo, outside. They are material. Even a scribble of a number. And this is similar to Robinson Crusoe and the scores he made to check. I don't know if it was for eggs. Well, let's say it was eggs to make it a bit simpler. Those are done actually. So imagine mathematics to be less and less visible signs, but they're still done to a certain extent, somehow, somewhere. It is not nowhere. We still have legs. We still have hands. So thereby an infinite series does not do its own job. This would be becoming even clearer. The man who says, I'm ready, his life goes back for an infinite time, and who says to us, I'm just writing down the last digit of pi, and it's 2. Every day of his life he has written down a digit without ever having begun. He has just finished. He creates space in time and in space actual. That space is a reductio ad absurdum of the concept of infinite totality. So what seemed to be so transcendental and abstract is quite practical. We have criterions. So he wouldn't do as Hilbert did, and he definitely do not agree with Gödel here. It's pretty easy here to see why they clashed. Gödel had no of the practicality. He didn't know that digits were actually doings. For him, they were abstracted from nowhere, living their own life somewhere, or actually without thinking. Because for the irrational numbers, the real numbers to work, they need a practice. They need the science. They will not work by themselves. We can see in the last sentence of the 3rd paragraph, just before the new article or new subchapter. Of critical importance is his claim that there is no rule, no systematic means of defining each and every irrational number intentionally, which leads him to question whether there is a criterion for the irrational numbers being complete. And complete, we recognize from Gödel. Complete mathematics, all of it. And he shows this complete doesn't mean anything. It doesn't have a sense to it. The next page, that will become even clearer. Second or third paragraph, whether you count the little paragraph at the beginning. And this is very important. Wittgenstein is critical of a tendency to employ metaphors deriving from geography. For instance, the claim that irrational points fill the gaps on a line left by the rational points. That's Hilbert's hotel. Just as we might claim that certain sediments fill the gaps in a rock left by igneous material. Such gaps do not exist. They don't make sense. But this way, a nonsensical room is created. And this is very close to the infinity of the universe. This stretch out universe comes from the idea that irrational or real numbers correspond to something of a mathematical space. What is closer to the truth? I'm here. My actions are needed for my understanding. If I don't do anything, I will not understand anything. So I couldn't understand infinity because it doesn't have a criterion. So this is quite a different way of approaching Gödel's theorem. He goes a complete different way. He's doing it the Wittgensteinian way. Once more putting our feet firmly on the ground as he usually does, but also showing that the transcendental and the abstract are existing because they conflate with use, a criterion. There is abstract thinking. There are criterions for it, but they do not work the Gödelian way in a Platonic universe. They're actually quite real. There's nothing unreal with them. And if they're not unreal, certain rules follows. And that is a complete extension of the number square root of 2 does not exist somewhere else outside of an act of our doings. What he calls law here. Look out, he's using law in a quite different way than we used before. And law is the certain way of doing. Oh, Kalle, please come in here. I know it's complicated.
Page
But it's good old,
might
it's good old Wittgenstein.
page 55. So this phrase here, to say that the expansion has no last digit is a clear idea which has nothing to do with time.
Yeah.
So the thing is that we mix numbers with time.
Because it takes time to count up all the decimals. Like that is space, it's also time.
It is true that often time and space can be interwoven, but here they are not. I will make an, I think, amusing example. I listened to an interview with Padre Amorth. He's an exorcist.
Yeah, from the movie. Yeah.
No, it's not to do with the movie. His publisher wanted that he would, the name of the book would be The Last Exorcist. And but Paramo, he didn't want this because this title because it sounds too bombastic, like if he were the last exorcist.
Yeah.
But then he thought, okay, why not? Because you could take in the word last also in the sense as you see here. Christ said, so the last shall be first, and the first last. So it doesn't have to anything to do with time.
No.
It can have like, let's say you have a line of people in front of a, say, bank or whatever, or a restaurant, you want to hurry, you will take the first. But then perhaps the owner of the restaurant say, go back.
Yeah.
In this case, it really doesn't, of course it has to do with time, because it takes more time for you, but it's more about the humiliation. And in this case, it's the humiliation and yeah, it's a humiliation. It's in that sense. And so here, so let's say that you have a, and we could also compare with.
Well, one thing you can compare, sorry to interrupt here,
please.
is from the former article when we spoke about present and past. And once more, you have the idea that it should be some sort of present criterion, not taking in the past as a rule, like we did with Tacitus for the guy with the murder complot, the murder conspiracy, or the chess player Achilles, or for that matter, if Julius Caesar blinked 2 or an even number of times. Here, everything is in the present. And that doesn't make any sense. We need a criterion for knowing these things. So it's not a lack of transcendental power in the world. It lacks criterion. Nobody does it. Nobody does these things until they're done. It's nonsensical to talk about them.
So he says there is no, let me see, where does he say there is no last, there, we could say that there is no last digit.
No.
This is, and we could take this also as an example, 0.333, that is, you say third.
Yeah.
And then you think this is somewhat real. But this doesn't really make any sense.
No.
Like in, you remember perhaps Terry Marks-Tallow, a paper by her, she mentioned the example that average family has 2.5 children.
Yeah. It's similar. It's not bad. Yeah, I think the parallel is good.
But I think that the best comparison, after all, perhaps, is with chaos theory. You remember, let me see, the name disappears from head. Who was the guy of the chaos theory? The better, he left.
Konrad Lorenz.
Yes, Lorenz, thank you. He.
With a butterfly.
Yes, he thought that if you only changed one small number, let's say.
We can use this. Very good point, Kalle. Because if you turn around and look at that space, everything is equal. And it doesn't make any sense what Konrad Lorenz discovered. This is the case here. Very good. It's a sort of doing. So it doesn't have this space connected. And of course, when you mention the butterfly effect to someone, like me, say I haven't heard about it, I will open my jaw. It's a jaw dropper. And that is weird. Would you think that the person from the Middle Ages would do that? Do you think a Roman would do that? My guess, he wouldn't. Because this idea of, if you see here, this is bigger, this is smaller, that comes actually from the newly invented space. It comes during the later Middle Ages, and as Lakoff Johnson, it's a construction. It's helpful, but don't misuse it. And then all of a sudden, if for Wittgenstein, chaos theory would be a surprise. It doesn't seem that the flapping of the wings of the butterfly are smaller than a tsunami. Because in what mathematical space would you compare them to? Who's the observer seeing one is smaller than the other?
Yes. So let's say compare this with continue comparing this with chaos theory, is 0.333. That I am saying Lawrence in his studio office.
Yeah.
He wanted to predict the weather, I think.
Yeah.
For the next day. So let's
Yeah.
say that he wanted to predict the weather for next day, and then he puts like 0.33333, but he was, I think, lazy.
No, he was in a hurry.
He was in a hurry. Okay,
He wanted to have a
in
cup
hurry,
of coffee
so-
somewhere.
So in this case, he perhaps changed, instead of saying 0.333, he put 3 ones, let's say.
No,
Says-
he more or less, instead of putting 0.33333,
Mhm.
he put 0.333. So he cut it out.
Okay. But for Wittgenstein would have liked that in one way. Why? Because he says that that's more real in one way. Because these adding things with it makes it very unreal.
Yeah.
Because it's I'm simplifying it. But okay, so let's say that he was lazy or in hurry, that he put actually he had only 4 trees after let's say
Yeah, I think it was actually 4, yeah.
let's say that let's say something like that, and that resulted in a completely different scenario
Yeah.
for tomorrow.
Which doesn't make sense with the idea that it's like with space. It should be an equal amount. Like if I put 1 kilo extra on the weighing scale and I had 2 kilos there, it should be a little bit more. This doesn't make sense from that perspective. But it makes excellent example if you don't have that space. And remember what Lakoff Johnson said, it's a pretty new invention, the idea that see mathematics as higher. You compare it with length, so bigger numbers are actually larger. In other cultures, that doesn't exist. In the Amazon, they don't have that. We invented that. It's practical.
But let's say that he was not in hurry. He would have only put a lot of trees there.
Yeah.
Let's say that would have resulted in good weather, while the opposite, that actually put one last tree there, point only 4 trees, let's say, and that resulted, let's say, in a storm.
Yeah.
But that is still an abstract plane, isn't it?
No, the storm actually happens.
Mathematically speaking, or how can we say it reflects reality, so to say?
Well, the odd thing about this example is it actually changes reality in some ways. It's observer related. And how that works would be the story for a quantum mechanical parallel between Wittgenstein and, the new physics. Because it makes a lot of difference. 1 decimal less, you get a different reality. So you seem to be thinking, or we all seem to be thinking, that the future is cut in stone. It's not at all. But I know what you mean. I still think the same thing. I would say the weather tomorrow will be whatever it will be, no matter what you do for sort of predicting in a laboratory or inside your house. That is not exactly true. Crazy, isn't it?
Yes, okay. So, so the difference is between indefinite, like dots, or definite, only a few numbers. And Wittgenstein is against the indefiniteness because it takes away all responsibility from you.
Yeah, you're still responsible. This is what Wittgenstein showed. You still do mathematics somehow, even those doings are very small. And of course, this is also a massive.
But there is actually replying that very thing that usually what he did
Mm.
is that he let it be a huge amount of numbers, okay, and they computed it the rest. But in this case, he made a decision, or
Yeah. He made a decision. Yeah.
and that decision was that we need only 4 numbers,
Mm.
and that means that the question is between computers and the human being. That is actually you do the decision, and that changes everything.
Yeah.
But by the
Yeah, think about it. I think maybe we should.
Yes,
it's a difficult subject, and it's 4 o'clock in the afternoon. But this might be helpful. This is a definite blow against the idea of determinism, both in time and space. Because we all have that intuition. I saw your face, and I felt the same thing, that the weather somehow is fixed. What Konrad Lorenz does in his laboratory won't affect the weather. I'm sorry, it does actually. To what extent, we cannot know. But it does have a butterfly effect itself. So on that note, we end this lecture. Thank you very much, Kalle. Thank you everyone for listening in. Have a very pleasant morning, day, or afternoon. Bye bye for now.